by hand, but then we'll do it on the calculator. And I would probably recommend using the calculator. But just in case anybody's first doing it by hand, that's okay. So, I might give you a number line, or maybe you'll just sketch a number line. I'm going to try to get a little more detailed on this one. Our lowest price one was 19. So I'll leave a little. I'll go 15. I'm going to go by 5. So you start by making a box, and you use your quartile 1 and quartile 3 as a guide to where you put the sides of the box. So 22 and 39, that's where we'll have the sides of our box. And you don't have to label them down here. I'm doing that for your benefit. But you might want to for your own benefit. You're eyeballing things. So from Q1 up to Q3, that box represents the span of essentially the middle half of your day. So the middle half. Then there's a vertical line at the median. Yeah. So the vertical line at 29. If you don't have any outliers, you have horizontal lines called whiskers that go out to the min and the max. We don't have a lower outline. So we will have a horizontal line that goes down to our min, 19. It's called a whisker. Now, we have an outlier up here at 68. Our maximum turned out to be an outlier. And outliers are denoted with some kind of symbol, like an asterisk or something. If you have an outlier, you don't make your whisker go all the way out. And you could have more than one outlier. The fences, some software, or the boundaries, some software will put the boundaries on the graph, but we're not going to indicate the boundaries on our graph. We just use them to decide whether we have an outlier. We're not going to show them on the graph. So the whisker is going to stop at the next data value inward from the outlier. So 68 was the biggest. What was the next biggest? Looks like 41 was the next biggest number. So if the numbers are in order, so 41, that's where our whisker is going to stop. So it's a nice visual of your data set. If we didn't have any outliers, that whisker would go all the way out to the max. But the calculator will do it. You don't have to draw it by hand. How do you do it? That's what we're going to do right now. So on the calculator, you just first note where your data is. You would enter the data if it wasn't already in there. So mine's in list 2, so I keep that in mind. Then you press second y equals And you're going to turn on one stat plot. Is there anybody who has plot 2 or plot 3 that says on?
Where do you click once you first do
Oh,
this?
press second, and you don't need to be in the list at all. I just went there to see where the data was. But to get to this screen, you press the second button and the Y equals button. Second button, Y equals. I think the directions are on the back side of your yellow sheet, but remember you can write on your yellow sheet. So if those directions don't seem clear to you, you can write down extra directions. So, is there anybody who is not at this screen? Okay, so once you're in there, look at numbers 2 and 3, and you want those to say off. 2 and 3 say off. Then go to number 1. Just go ahead in there. If you followed along in last class, you may have this all set up already, but press enter to turn on, just in case it's off. And then you want to choose this type, and you get to this type. It's the box plot that has a little couple dots to the right side. To get there, you press down arrow to go to type, and press the right arrow 3 times, I guess. Down arrow to get to type, 1, 2, 3 to get over to that one. And then you press enter to select. You do have to press enter to select in here. Then go down, tell the calculator which list the data is in. I have to press enter. Then the mark that you want the calculator to use to display any outliers. I recommend not using that dot. A couple times in the past, when people have used that dot, they didn't notice the outlier because it was not extreme, and then they asked me afterwards how they missed that, and they said, well, I still have the data in the calculator, and we look, and it's because they used that dot. So any of these 3 is good. You just want it to be noticeable. And then all you have to do is press the zoom button. But is there anybody who's not to that point? Press question. Then press zoom number 9. Zoom number 9. It generally gives you the best window for statistical plots. And did anybody have any trouble or any questions getting there? Okay, and the nice thing is you can trace. If you don't remember where you stopped the cursor when you have an outlier, you can just press this trace button and then use the left and right arrows. And you can totally use the calculator to do your box plot on the test if you want to. I wanted to do one by hand so you remembered you had a good feel for what it represents, but it's fine to just press trace and then use your arrows to move around in there, and it'll give you your 5-number summary also. Yeah.
Are you using the same list that you used that one? Or is this the different list?
That should be, good question. I believe it's the same list. Let's look. 19 is for the man, 22, 29, 39, 41, and 68. It is the copy. Yeah, it is the data in number 14 on page 145. So it's the copy maker data. I have it in list 2 here. I knew we added an outlier to one of our lists, but it's that 19, 22, 29, 68, and so forth data set we had earlier.
But you're doing it for list 2, right?
Yes. But you choose whichever list that you put your data into. Let me see what you got there. Yeah, that looks good. Let's see. Oh, okay. You want to list 2. Now, you chose plot 2. can use what one or what two,
Okay.
but then in here you would put this two.
Yeah.
Anybody, else, any questions at all? If you haven't used these calculators for another class, really need step by steps. Okay, then, where are we? We did the color boundaries. Okay, I have a star. The next one I have listed is number 8. On page 146, and I have a star by that. So definitely want to look at that one. So records at a hospital show a certain surgical procedure takes an average of 162.8 minutes, standard deviation 4.9. The data are approximately bell-shaped. Between what two values will about 95% of the data fall. So if a problem is telling you a distribution is bell-shaped and it's asked in what interval a certain percentage falls, you go to the empirical rule. The empirical rule applies to bell-shaped distributions. And I think it's on your yellow sheet. You'll see there's 68%, 95%, and almost all. So it will be one of those three. Later, I think it's chapter 6, you'll learn how to find other intervals and percentages. Yes?
On the umbilical rule, do we have to calculate something like that? Because on number 27 for section 3.2, I didn't understand.
Number 27, section 3. On the test, you'll have one like this. Let's look at what 27.
It's page 120.
Okay, this is like part B on that problem. So this is like part B. I didn't put one like part A. So it's almost 2 o'clock. So let's go ahead and do this, and if we completely get through it, we have this one and we have one other problem. I don't want to do part A on that one, and part B is just like this. After you take the test, if you want to come up, we can do that. But I don't want to muddle people's thinking right before. Okay, so you will either have 68%, 95%, or almost all. So you just look at the list of the empirical rule, see which one you have, and use that formula. So for 95%, you would go 2 standard deviations. On either side of the mean. Most of the data for a bell-shaped distribution, it's close to the mean. So you don't have to go out too far before you get the bulk of your observation. And they gave us the mean. The mean is 162.8. Standard deviation of 4.9. So it's just a matter of plugging in correctly and then putting that in your calculator. If you do it in steps, of course you always multiply before you add or subtract. comparison. So the vast majority is going to fall between 153 and 172. If it had said 68%, you just would have used a 1 there. And if it said almost all, use a 3. That's the only variation you might have. And then the last one is number 13. Oh. Well, we can do this matching thing. We might as well, but the thing on the test is I'll give you a graph and I'll ask you to shape. So what shape is this one? Skewed left, good. Skewed right. Skewed right, and bell shape. And this is the only one that you can use the empirical all the time. If it's any of those other ones, you can't. On a box plot, if you have skewed left, this lower 50% of your data is more spread out. Because this represents the first 25% of the data, that's the next. So that lower half of the data is really spread out. So this one has to be number 3. We have 2 right skewed ones. So here's the right skewed, upper half is spread out. Remember that median. These are outliers, right? This one, see that little thing out there by itself? That's probably where some outliers are. So B and C, it's a little tricky, but I would say number 1 is B because that looks like an outlier. There's a big gap. This is really skewed right, but a lot of this stuff is way out there. So, and then nice and symmetrical. Tails are longer because these tails are more spread out. Things are more clustered for the center, so you have shorter bars. But as long as you know the shapes of those, and this is the only one you can use the empirical rule on, you're going to be okay. So let's go ahead and do the test, and then if some of you still have homework questions you want answered, you can ask me quietly, or wait until everybody's gone and we can talk freely. Why don't you take a little break?